Hey, this is Ali Amagasu welcoming you to this week's episode of Cloud Unfiltered. Good afternoon, good morning, good evening, good whatever it is, wherever you are, as our hostess, Nikki Acosta, would typically say. Today, Nikki will not be with us, but I am joined by Valid Benencosa from his SeaWorld room.
Hello, good to be here.
Today, I'm really excited to introduce a guest that we've had on before. This is going to be our first repeat guest. And I can say we didn't hesitate at all at the opportunity because his last episode was extremely popular. I wouldn't have called that. The main topic was VPP, Vector Packet Processing, for those of you who aren't familiar with it. And man, do people want to listen to chit-chat about VPP. When it first came out, it was our most popular episode. So we didn't hesitate to have him back. We're going to get an update today on what is going on with VPP and how that all relates to the upcoming KubeCon and some other things. So I'm pleased to welcome Ed Warnicke. He's a distinguished consulting engineer at Cisco. Welcome, Ed.
Good to be back.
Thank you so much for joining us. Now, for folks who missed the first episode and tuned into this one, can you give a quick summary of VPP, why it's exciting, why it got so much traction as a podcast episode, and why people want to see you on stage so much talking about it before we go into what's new?
Why do I even care about VPP?
Yeah, I get that a lot. No, the reason the VPP, so I'll sort of give you my 30-second drop the mic version and then a slightly longer version. The 30-second drop the mic version is that VPP is a pure user space virtual router, virtual switch that can forward a terabit per second of traffic on a commodity server with millions and millions of routes in the routing table. And you can sort of just say that, drop the mic, and walk off stage at some point. But when you dig deeper into it, what you really have is not just sort of the simple, it's faster than hell, and it scales unbelievably, but it's also incredibly feature-rich. More and more of the networking is moving, more and more of the network edge is moving into the servers. The kinds of sophisticated things that people want to do with networking on a server in a virtual switch are starting to rival the kinds of things that they used to want to do on their physical edge devices and on other interesting things that used to live deeper in the network. And so having more sophisticated features like, some of which many people haven't heard of, but they're really, really cool in what they can do, like segment routing, having all the sorts of end caps that people want, not only simple things like GRE and VXLAN, but VXLAN GP, being able to layer them so you can put MPLS tagged packets in GRE. This becomes really very compelling. And so what it really comes down to is whatever interesting creative thing you think you want to do with networking, you can do fast and at scale and in user space. And the user space is actually really critical because what it means is that as you move the world towards containers, where containers, you're breaking a chunk off and isolating a chunk of what's going on your server and letting it run, you still in that container are sharing a kernel with everyone else. So you can't do strange jiggy things in your kernel. But you can in the user space piece of your container. So if you want to do something creative with networking, you can use VPP for that within your container. And it gives you an exciting degree of flexibility as a result.
I love that answer. My takeaway was that VPP is going to let me do strange, jiggy things in my container. And that's relevant to my cloud audience here.
Yeah, choice of words.
No, that's great. We need that. It needs to be simplified. I mean, there's a lot of... especially at companies that are always pushing forward and pushing the edge. I think there's a lot of shop talk. We get lost in our shop talk, and sometimes we forget to simplify it for all these poor customers who are just trying to catch up and figure out what is best for their systems, right?
Yeah. So
good.
So what are the updates, Ed? Like, what's new? What have you guys been working on since we talked with you last? And
yeah, so there are a lot of things
previewing
that are continuing to improve in the system. We were demonstrating recently a lot of stuff around NFV in basically container-based NFV, where we were showing massively faster performance that you can get with any kind of interconnect between VNFs that are living in containers on the same server using a technology called MEMIF. We have a modular high-performance user space host stack, so that basically you can bypass the kernel for doing TCP for your applications. And the host stack itself will scale to 10 million connections simultaneously going 200,000 new connections per second. So it's really fast and really scalable. And you might sort of legitimately wonder why you care about something at that scale. But as the number of containers that you are running on a server keeps going up, right? Right now you might be running 100 containers on a server. As the number of cores goes up, you might be running 1,000 containers on a server. Well, if you're running 1,000 containers on a server and you have a TCP stack and you want to be able to provide some reasonable connections per second for all of them, you've got to really be pushing the threshold in terms of what your TCP stack can do for you. And the VPP user space TCP stack can do that. It also happens, I mentioned the word modular earlier. This is also really important because what it really gives you is it gives you transport, which happens to be TCP, and it gives your applications an API they can talk to, which we can give you either the native socket API that everyone knows and loves, so your application works without change, or if you're really, really grinding out every last bit of performance, we have an API that will allow you to interact with us even more quickly than the traditional socket API. But the modularity is important because TCP just happens to be the transport. There are new and interesting things happening in the world around transport layer protocols. Google has been pushing Quick. So right now, if you're in a Chrome browser and you're talking to Hangouts, there are a bunch of things that instead of a few years ago would have been using TCP. Instead, they're using a new protocol called Quick, which is faster, more efficient, has a lot of positive characteristics around streaming and solves a ton of problems that you would have with TCP. I mean, TCP's been around for 30 years now. It's longer than, some of the engineers working on it are younger than the protocol, for God's sake. And because we are pluggable, that means that you can plug in other transports as they come up. You could plug in a transport like Quick. You could plug in a transport like SCTP. Or if you're a university researcher who wants to go research transport protocols, you now have a route to having your research get into reality.
So, so there's some. I'm still trying to just get my head out. I'm sorry. The things that you're going to be up that's new that you've been doing is it's more modular. So you're looking at new different protocols, and then I got
carried away. Apologies. Let me go back to that question. So one of the really important things that's been happening in the last few months in the sort of FIDO VPP world is a lot of work on integration with Kubernetes.
Okay. Yes.
And that gets to be really important because Kubernetes is the orchestration mechanism for cloud native, right?
Yeah.
Which is basically going to be the future of, if not the present in many cases, of how most people run their workloads. Because the number of workloads that can't run in a container that have to have a full-fledged VM is very small, and containers are so much lighter and more efficient.
Yeah, totally.
Absolutely. And so we've been integrating VPP into Kubernetes, which has been a fun and interesting exercise. So you had commented earlier about bringing this down to the level where everybody can follow. It turns out that gets to be a really fun exercise when you bring deep networking people into the Kubernetes community, because the cloud native guys, they really don't want to know about things like subnets. They don't want to even know, any more than they have to about IP.
Right. Don't care. Just want it to run my app.
Don't care at all. The things they care about are relatively few. I usually talk about them in two groups. The first one is reachability and isolation, which is every pod has to be able to reach every other pod at L3.
Yes.
How that happens, it has to happen.
Right.
Unless I have a Kubernetes network policy that says, oh wait, this pod should be isolated and only these people should be allowed to talk to it.
Yeah.
Right? And so doing that. And then the second thing that they care about is basically what's generally called service discovery and service routing.
Yes.
How does this microservice find the next microservice in the chain of things that we're doing?
kubedns. No?
Sorry, what?
kubedns, right?
Effectively, at the end of the day, it's kubedns plus the Kubernetes services, which will handle your load balancing and all that other stuff. Right? Yeah. And then a bunch of magic happens under the covers that you neither see nor want to see. Right?
Yes.
And one of the things that's quite interesting as you do this is that the available set of magic under the covers in VPP for how you achieve these ends increases, and your ability to do things that people do care about also goes up. So I'll give you a really good example. I like to say that DevOps people like the network to be completely invisible up until the moment where something goes wrong, and then they want it to be completely transparent.
That's very true.
You don't want to ever think about the network, but if something odd is happening, you want to be able to see as much as possible.
Yeah.
Right? It's sort of this very fascinating dichotomy. One of the things that VPP will be able to bring to the party here is something called in-band OAM. And in-band OAM is a mechanism where we can stick special tags in the packets so that as they're moving through the network, at every hop through the network, you can get telemetry information, timestamp information, etc., so that you can know, okay, I'm seeing this wonky thing from this customer to this app, which is going through a chain of 20 different microservices to do its job, right? And now I can see, okay, I can see the latency hop by hop from the customer to the first microsystem service, hop by hop as you go, through the next microservice, etc. And you also have the capacity with IOAM to ask for packet captures to be sent to a third-party location for the flows that you match on. So now you can even see data captures as you're moving through. And this is really critical because as you balkanize to more and more microservices, which is the way things are going, that level of transparency, right? Complicated systems are great until they fail. I think it was Tannenbaum who said the definition of a distributed system is an application where some system you've never heard of has a problem and it breaks your application. And so being able to
it was either him or Gandhi, I'm not sure, but maybe, yeah.
Exactly. So I mean, these kinds of cutting edge features can be brought to bear on the system, and the rate of evolution of VPP is much more rapid than what you would get in the traditional kernel world. Releases come out every 3 months. Everything can be done as VPP plugins. So we literally have people at the IETF who are saying, we see this problem. Here's a protocol we think will fix it. Let's do a hackathon the weekend before the IETF meeting, and we'll just bang it out. Right? That's happened a lot.
So the Kubernetes stuff is actually really exciting because I remember last time one of my questions was how does the average Joe user like myself get a hold of this? And so you're making it available in Kubernetes. So how does one take it and get the benefits of VPP inside of Kubernetes?
Yeah, so I mean, the standard way that one installs networking in Kubernetes, and this is just sort of keeping with the Kubernetes notion of the world, is you type kubectl apply -f some file.yaml.
Yeah.
Right? And that's very much where we're trying to go with the installation for this as well. So let me talk a little bit about the pathway that we're taking for the Kubernetes integration. So VPP is just a data plane. And one of the things we discussed last time is it's completely agnostic about who's in charge. It does not care what its control plane is. It just cares about moving packets. So anyone, Flannel, Weave, Calico, any of these guys who actually do networking for VPP, or networking for Kubernetes, could use VPP as their data plane. It's completely agnostic in that sense. But there are a group of folks in Contiv who are working on the Contiv VPP integration, so that if you use Contiv for networking, you can optionally use VPP as your data plane and get the scalability, performance, density, and efficiency gains. And then as you start to see more features coming online, take advantage of those as well.
Well, why wouldn't I want VPP just to be the default all the time? Because it's just using OVS right now, right?
It depends on whose networking you're running. The Kubernetes space, there are a lot of different people with a lot of different opinions about what the right networking behavior is.
Yeah.
And I think the response from the Kubernetes community has been the correct one, which is make it trivially easily to agree to disagree, and it doesn't hurt anyone. So they've made it extremely easy with things like CNI and CRI and a bunch of the different touch points that they have in the system to simply say, okay, you think we're doing it wrong. Here's your point to plug in, your extension point. Go do whatever you think is a good idea, and we'll let the market sort it out.
Yeah.
Right?
On your previous episode, you talked quite a bit about open source communities. And you just, your mention of the Kubernetes community made me curious. How do you feel they function? We talked about functional kind of and dysfunctional open source communities. What's your opinion on that?
So far, my experience with the Kubernetes community and sort of what I'll call the extended Kubernetes community has been really, really positive. So, and I say the extended Kubernetes community. So, Kubernetes lives in the Cloud Native Compute Foundation, which has more projects than just Kubernetes. Kubernetes itself has a bunch of sub-communities under it: the network SIG, the storage SIG, the node SIG, the scalability SIG, they have SIGs for freaking everything, which is actually an incredibly healthy sign in a community. Because when you have a mechanism for people who care passionately about a particular niche of your community to gather together for warmth, that's always a good sign. So it's been very, very positive. They've got good standard ways for how you find those different communities, how you find out how to engage with them. They hold fairly regular meetings where anybody can speak up. They're welcoming of new ideas, but also sort of hard-nosed about what is sort of the, if you will, sort of the spiritual underpinnings. Yes, you have an idea, but these are the reasons why it sort of isn't spiritually aligned. Let's see if there's a different way to solve your problem. Kinds of stuff. So it's been overall very positive. And then when you get even further out into the extended community, you start to see things like Istio and Envoy coming in, and those are incredibly exciting. And I suspect there's a great deal of interesting work that VPP could contribute to moving them forward as well.
That's great to hear. It's interesting. We had a guest on last week. Actually, his show hasn't been publicized yet, I don't believe, but he was talking about OpenStack and the Big Tent and how they're moving backward from the Big Tent, some of the mistakes they've made. He argued very vigorously that OpenStack is still relevant and needed in certain spaces. It's just not what they originally thought it would be. Right, right. Do you think there's any mistakes that the Kubernetes community is making right now? Something similar. I don't know if the Big Tent was a mistake, but it's certainly something that OpenStack is backpedaling from right now. They recently certified, 32 distributions or 34 distributions of Kubernetes. Any opinion on that?
Yeah, no, so I've not seen Kubernetes make any major missteps. They seem to be moving very deliberately. One of the things I can tell you is the stock thing that I say to everyone I talk to about the Kubernetes Network API is they have done an exceptionally good job as far as it goes, which is to say the set of problems they tried to address, they've addressed really, really well. It does not do everything that one could imagine one would want to do. But it's progressively, in a very careful, thoughtful fashion, extending itself to handle those things. With the right kinds of underpinnings, basically, let's try and keep this as simple as possible for the user. Let's think a lot about what the user actually cares about, right? So, for example, if you ask around with DevOps people, the first thing you will discover is no DevOps person ever wants to know about a subnet ever again. Ever. So what you very quickly discover in Kubernetes is, yeah, you never have to know about that, ever. Right? People don't want to have to go stitch together complicated things around IPs. So, for example, we talked about the network policy API in Kubernetes, where you can say, okay, this pod can only be talked to by these people. There's not a single IP address when you're talking pod to pod in the specification of that ever. Right? And this is really important in Cloud Native because pods appear and they disappear really fast.
Right.
So if you go update that yourself as the application author, you'd be rapidly driven to hara-kiri. They've done a lot of those things very, very well. I've not seen any major missteps.
That brings us to KubeCon. It's coming up. I know you're going to be there. I've never been to a KubeCon before. Is it exploding the way the OpenStack Summits did? Is it a good show? What's great about it? Why are you going to be there? And will you be available for people who want to learn a bit about VPP if they happen to track you down wandering the halls?
So I will be at KubeCon. They generally speaking are very fun shows. I think you are seeing sort of this center of mass energy moving towards them, where they're picking up the kinds of momentum that you saw with the OpenStack summits. Basically, in large part because people are realizing that Kubernetes and Cloud Native is sort of the future where they want to go for most of their workloads. And so people are trying to line up with that as much as they can. So, it tends to be a good show. There's a lot of activity going on. We'll be having a FIDO mini summit at Kubernetes. So there will be an entire day mini summit on Tuesday, December 5th next week, where you will have wall-to-wall talks about data plane, with a lot of focus on the kinds of things that we can do to make the container world a better place, right? So that will be going on. There'll also be other interesting things around Istio and Envoy happening. And of course, it's a huge chunk of things that people are concerned about in the scope of Kubernetes, and they've got well-formed communities around many of them. So I will definitely be there. As I said, I will be at the FIDO Mini Summit on Tuesday. I will be around in general. People who are used to interacting with me at conferences know that I am delighted to have people wander up, pull me aside, ask questions, throw stones, make jokes.
But so Ed, you will be accessible. You won't have your hundreds of entourage people around you, or is that how we know how to find you? We just look for the big crowd.
Yes.
Well, not the crowd, but if you start looking around for trouble, that's often me. Well, among other things, at the FIDO booth, I am told that we will have a live puppy.
A live? There will not be a live puppy.
That is what I am told, that we are getting a puppy at the FIDO booth.
Oh my gosh, what a great idea.
I respect that. That is a take no prisoners approach to event management.
I just want to go up to the puppy right now. I'd give him a little.
We're not giving away Lego boxes. We're bringing in live animals.
We'll let you pet a puppy.
Well, not only will we have a live puppy, but the things that we give away at our booth are we give away these really cute little stuffed dogs with a FIDO cape. It's adorable. I don't have them to show you right now. People keep stealing them from me.
Very cute.
I gotta ask one question just to follow up. So the way VPP is available now, that a person could get it, is that there's being work done in Contiv to make that happen. Is that how I could use that in Kubernetes today?
Absolutely. If you go look at the Contiv VPP repo, the work is actively being done there, upstream first, patch by patch. There's a lot of activity happening. Happening there on the sort of meeting the basic Kubernetes networking needs. And then I was just talking to the Envoy community last Tuesday. It might have been last Tuesday, about some of the things that we might be able to collaborate together on there. Are you guys familiar with the cool stuff that's happening with the dawning of the age of Istio?
I was going to ask you, what's all the hype about Istio? Like, why? I saw that in the Cisco Google Cloud announcement. I'm like, I don't get it. Like, it says it's supposed to be the services, Swiss Army knife of internet services, whatever. I mean, help me understand it. What's all this hotness about?
Yeah, every bit as cool as everyone sort of is saying. I think they're still converging on clean messaging about explaining why.
Yeah, that's the thing I'm not quite.
Yeah, so I mean, here's the thing. This is back to thinking about what you care when you're DevOps and what happens when you get to a world where you have lots and lots and lots of microservices going on, right? So let's take a really simple example, right? I have a website and I have, let's call it example.com. And when you go to example.com/blog, I want to take you to the microservice that is serving my blog, right? When you go to example.com/fac, I want to take you to a little tiny static Nginx instance that's serving a bunch of static pages for my fac. And these are totally different systems, right? And the decision about where you go is being made not at L3, not at L4. It's not about IP addresses. It's not about ports. It's being made at L7. It's being made at the layer of HTTP. And what Istio allows you to do is say, okay, I want example.com/blog to go to one of the following pod instances that are serving my blog, and Istio.com and example.com/fac to go to one of the instances that are serving my fac. Now, as you get more granular, because it can make these decisions not just on things in the URL, but also on other headers in the HTTP request, on cookies. Some of those cookies, for example, might identify the user. So, for example, I might be able to, if a particular user comes in, direct that user to a specific microservice whose purpose in life is serving that user.
So is it like an ingress controller on with more capabilities then? Because I mean, when you describe like routing to the different pods, it just reminds me of what an ingress controller does. But so this an ingress rules. So does Istio just go a bit beyond that then?
It goes quite a bit beyond. So the stuff I've described, you're right, is very close to sort of semantically what's happening for ingress. And I often, when I talk about Istio, I'll usually say Istio Envoy because it's actually two pieces.
Oh, really?
Think of Istio as sort of the global control plane piece, and Envoy as the sort of L7 HTTP proxy, reverse proxy data plane piece, right? And so with Istio, that's where you come in and describe what you want your service mesh to look like. And you can do very sophisticated things there, much more sophisticated than just routing on URLs. You could do things like saying, I've just deployed a new instance of my pod, so send 1% of the traffic.
Oh, yeah. So now you get like A/B blue-green testing.
Absolutely, canaries, everything. But they can also do really interesting things that are obvious once you think about them, but which were not immediately obvious until they were pointed out. So you could inject faults with Istio. Now you might ask yourself, why the hell would I want to inject faults into the system, like additional latency, dropping of TCP sockets occasionally? Well, as we're moving to a world with something like Spinnaker, where I've got continuous delivery, where I'm doing my development, I roll out an instance, it's the same underlying cluster I'm deploying to for my CI testing as where I put my production instances, and the only difference is after the instances pass CI, then I roll them into production. Well, if I'm testing something, I kind of want to know how it deals with things when the world is not ideal.
Right.
And so Istio is bringing all kinds of things like this into play. But then when you get down a step further and you look at how Envoy is providing this service, what they've done is in every pod that gets deployed, you deploy an Envoy sidecar. So in a Kubernetes pod, you could have multiple containers. So you have some containers for applications. You deploy a container with Envoy in it, and you send all the outside traffic that's coming in to Envoy first, and then it can decide what it wants to do in terms of communicating to your local applications in the pod. And when your pods go to talk to the outside world, it also goes to Envoy first. And so literally, they've taken the data plane for the service mesh, and they've put the pieces out right next to all of the applications. And this lets you do all kinds of really interesting things in the system.
Oh, wow. One thing, you said Spinnaker. Is that like a chaos monkey for containers thing, or what's?
Yeah, well, I mean, that's one way of thinking about it. It's a system. It's an open source community that is basically expanding on the CI/CD concept to move more towards continuous delivery and do more sophisticated things on top of things like Travis and Jenkins.
Oh, wow, that's awesome. Yeah, no, okay. So I feel a bit more educated on the hotness of Istio and Envoy.
There's a lot of hotness in Istio and Envoy. It is every bit as cool as everyone who shows up and says this is amazing, and then they can't quite explain why.
Well, you just did.
Amazing as they're telling you. It's just everything really cool, particularly when you're doing something innovative. When you do really new innovative things, it takes a while to figure out how to explain them. And I think part of what's going on is Istio is going through the not particularly easy process of getting their messaging to converge.
Yeah, and well, and even people might think that of containers when you explain that to somebody who's never even heard of it, right? It's like, why do I want a container?
Right.
Baby VMs, right?
Well, and like I was asking last week, why should I be excited about serverless? And that kind of got me thinking. There's a lot of energy right here around Kubernetes, obviously, and how VPP plays into it, and it makes me wonder: is serverless going to be the next Kubernetes? Is it going to make Kubernetes? Is it going to make containers irrelevant? What do you think about that, Ed?
Well, I mean, when I think about serverless, I will tend to think about it in two pieces, right? One piece doesn't seem that fascinating to me. So the first piece of, let me talk about the two pieces. With serverless, you get people who want to talk about, here is my Python script that does something. I'm just going to give you the script, and you're going to go run it in some reasonable fashion for me, right? And in some sense, this is a packaging piece. It's saying, let's go even lighter than containers for packaging. And at the end of the day, you're still going to need things like isolation. And so even in cases where you're looking at serverless as a packaging mechanism, all you're really going to do is hand it over. Someone's going to wrap it in a container for you and send it on its way. And that may make life a little bit easier, but it's not a huge jump forward. But on the other side of it, there is something, as I've been thinking about serverless lately, as an activation pattern, right? So we were just talking, please note, this is all not completely come to fruition, but we were just talking about how with Istio, you could literally spin up a microservice per user. So imagine a situation where whatever your criteria is for spinning up a new flavor of microservice to deal with a request, where if a request comes in for that, you could spin it up on demand. In other words, you could treat the request as an activation pattern for the serverless instance.
Yeah.
And as we're getting to a place where you can spin up containers in, where you can spin containers up in milliseconds, and where you've got this serverless concept where you start thinking about the world in an on-demand way, right? You think about the life cycle of the request in serverless. You don't think about the life cycle of the server. I think that activation pattern piece is far more fascinating to me than the packaging piece.
That is a really interesting concept. Yeah.
I mean, and more than anything, I think serverless is about the shift of focus away from life cycling the service and more to life cycling around the request.
That's a great insight. Thank you. I feel like it's still new enough that we're still, kind of climbing that hill as far as momentum and interest in serverless. Whereas Kubernetes is at like maximum excitement right now, and containers, it's what everybody wants to talk about. And serverless is just this little hint kind of out there on the horizon that's suggesting it may be big, it may not, we don't know.
Well, and quite honestly, I don't think there's terribly great agreement on what serverless is yet and why it's important. Everyone has lots of people have different opinions about what they mean by serverless, and lots of opinions about what the critically important elements of it are. And what everyone can agree on is that the word serverless is really good branding.
Yeah.
That is really good branding.
It is really good branding.
So Val, do you have any more questions? I think we've covered what I wanted to learn about, what was going on with VPP. So I invite you to ask more questions. And Ed, if there's anything that I didn't ask you that you want to cover about what's new with VPP or what's coming up at KubeCon. We've got a few more minutes left, and then we got to wrap it up.
I'll defer to you, Ed.
Yeah,
What other stuff?
Okay, yeah, I'm happy to answer the questions, but basically, my suggestion would be do come to the FIDO Mini Summit. Do go around to the FIDO booth. We will have a booth, not only to pet the puppy, but also to see the kinds of cool things that we're doing around integration with Kubernetes and the ways in which it can improve the performance, the reliability, the density of services that you run with Kubernetes. Because again, if we can manage to make the whole process more efficient so you can run more workloads on the same amount of hardware, that's a straight up CapEx story, right?
Yeah.
More workloads on the same amount of hardware is just a dollars and cents kind of thing.
Right.
Very appealing. Are there any other shows you're going to be at after KubeCon that we should know about that you think are interesting?
So there will be ONS coming up in March or April, I think, in Santa Clara. I will definitely be there. I'm not clear on others in there. I'm just trying to get through KubeCon right now.
Well, thank you so much for being on our show today, Ed. We really appreciate it. You're one of my favorite guests. You're so low maintenance. I can throw you like one question and we're good for 10 minutes.
That's the most way I've ever been accused of never shutting up.
I really appreciate it. And I do invite you to be back in the future. You're working on some of the most, exciting technologies that are going on right now, not just in Cisco, but in the industry. So we appreciate it. Everyone listening today, I encourage you to go out and find Ed and see what he's tweeting about on Twitter. Ed, where can they find you? What's your handle?
I'm at Ed Warnicke on Twitter. I realize
Perfect.
it's intuitive, but most people do figure it out eventually.
All right. Thank you very much. That's
Thanks,
it for
Ed.
now.
Great to see you, Ed. Thank you.
Bye-bye, everybody.